Alright, so this guy, Mr. Thrive and Survive, put out this video, and it's entitled Eclipse Proves Science and NASA Wrong. And I watched this video. I watch a lot of his videos because they're kind of interesting. And whenever I watch videos such as this, flat earther videos, I'm not a flat earther, but I kind of like to look at things from different perspectives as kind of, I don't know, as an interest. And when I watch something like this, I usually ask myself, well, okay, does what this person is saying make sense to me, or is something wrong? And if I have a problem with it, I might make a comment. And it's not to be antagonistic or anything like that. It's just to point out that I have a problem with what the person is saying. And so I do that, and I did that here. And maybe I was being a little bit rude. I said, I started off, what you show as a viewpoint from the sun is pretty flawed. So maybe I shouldn't have said, pretty flawed. Maybe that was too confrontational. I don't know. But we kind of went back and forth a little bit, and eventually he put out a part 2. Okay, so there is a part 2 to this video. Again, Science and NASA Wrong part 2. I understand part 2 less than part 1, and so I don't really understand the point he's making in part 2 at all. So I thought I'd make a response video. He's probably going to get all pissed off because I'm making a response video, but Rich, there's no point because I don't have an audience. Okay, I might get 10 people to watch this video, and of those 10 people, maybe 2 will like it, and the other 8 will think I'm batshit crazy. So there's no point in getting pissed off that I'm making a response video, and I don't even know if you're going to watch this thing. But people watch your videos, and sometimes they disagree with you, and because they disagree with you, it doesn't mean they're a shill, and it doesn't mean they're a defender of NASA. It just means that they disagree with you. So don't get too defensive, and either take what they have to say under consideration, or don't. But just sometimes I think you're a little bit too defensive about these things. So anyways, I'm going to go through my problems with these videos, and I'm not going to show too much of them because they're his property, but I am going to put links to both of his videos in the comment section below mine. Okay, so let's go ahead.
With this in mind, the Earth would have to be, I don't know, 500 times larger than what it actually is.
Okay, so let's ask a question. If the Earth casts a shadow, how will the moon appear if it is in that shadow? In other words, if it is partially eclipsed by the Earth, what will the nature of that shadow be? What will the size of the shadow be? So what I've drawn here are the sun, the Earth, and the Earth's shadow. Now, obviously, this isn't a scale. And the first thing I would like to point out is the nature of the Earth's shadow is going to depend on the source of light. So suppose, for example, ignore the large disk of the sun for a moment and imagine that the sunlight all emanates from one point. Okay, so it's a point source of light right here. If that were the case, then we would expect the Earth's shadow to increase the further out we go. And the Earth's shadow would be everything within this cone here, and as you can see, that cone increases the further out we go. And again, that's only if the sun were a point source of light right here, And obviously, if the sun were a point source of light, we wouldn't be able to see it anywhere inside this cone. It would be blocked. It would be blocked by the Earth. But of course, the way nature would have it, that's not the way it is. The sun is considerably larger than the Earth. So the cone that we should be looking at is this cone, okay? With the shadow of the Earth getting smaller the further out we go, and the cone tapering off. And that being the case, suppose we were, say, right here, and again, this is now, the sun is no longer a source of light. Imagine the full size of the sun, in reality, of course, a lot larger. And so this is the nature of the Earth shadow cone here. And if we were very near the Earth and just behind it, you know, with respect to the sun, then obviously we wouldn't be able to see the sun because the Earth would be blocking it. And the further out we go, the Earth shadow is getting smaller, so eventually we would be able to see the sun peeking out from around the edges of the Earth. In other words, what we have when we have an annular eclipse, where if it were a lunar eclipse and the sun is peeking out from around the edges. And then if you get very far out, then the Earth shadow shrinks essentially to a point and it becomes irrelevant, and all you see, no matter where you're at, is the sun. The Earth wouldn't eclipse it at all if you get far enough away. So on this slide, this is essentially the same thing as what I had previously. Again, the sun, the Earth, and the shadow of the Earth. The only difference is I've drawn a few lines in here connecting the center points of these disks, and I've added some relatively convenient right triangles. Okay, and these right triangles are going to help us determine the value that we want to determine, which is what the radius of the shadow of the Earth is at a distance of the moon. Okay, so this is what we want to determine, this measurement right here. So we have two right triangles, and for a right triangle, the tangent of this angle is equal to the opposite side over the adjacent side. Now, we don't actually have to worry about what that angle is, and we don't have to worry about the tangent of the angle, so we don't have to play with calculating the angle from the tangent or anything like that, because if you look, see, the slope is the same. Okay, so this angle, okay, in this triangle is the same as this angle, and since the opposite side divided by the adjacent side is equal to the tangent of the angle, then the opposite side here, this line, divided by the adjacent side, this line, which is equal to the tangent of the angle, that's also equal to this line, all right, on this triangle, divided by this line. Okay, so it's just a ratio of one triangle to the other triangle. So in each case, the adjacent sides are the distances between the bodies. So for the larger triangle, that adjacent side is the Earth-Sun distance. And for the smaller triangle, this adjacent side is equal to the Earth's distance from its shadow, and of course we're going to be putting that shadow on top of the moon, so this is the Earth-lunar distance. And then the opposite side on this triangle is, for example, over here, this side is equal to the sun's radius, all right, minus the Earth's radius. And on this triangle, this side is equal to the Earth's radius minus the shadow's radius. Okay, and so that is how we're going to determine what the length of the radius of the shadow is. Okay, so all I've done here is I've plugged in the numbers, and again I'm using kilometers. It doesn't matter what units you use. I just pulled these off of Google, and I've had them on the previous slide there for your convenience if you like to use if you like to play along and use the same numbers to see if you get the same values. So, okay, so I've just plugged the numbers in. So the Earth radius minus I'm sorry, the Sun's radius minus the Earth's radius is equal to the 689,929 kilometers divided by the Earth-Sun's distance. You can see I've just plugged that in. That is equal to, and that was for this triangle, that is equal to the Earth's radius minus the radius of the shadow. Okay, the radius of the shadow is what we want to calculate, divided by the Earth shadow distance, which is again the Earth-Moon distance, and that's, of course, the Earth-Moon distance varies between a perigee and a apogee. So this is the average value that I'm using. So anyway, all we have to do then, after we just plug these in, is we just rearrange things and we solve for the shadow radius, and it just takes a little bit of time on the calculator, and you find out that the shadow radius is equal to 4,598 kilometers. Okay. So one more thing here is that what I'm really looking to do is determine the radius of the shadow so that I can compare it with a picture, basically a still frame from Mr. Thrive and Survive's video. And so using these rather bulky numbers, they don't really mean anything if I'm looking at a picture. So what I like to do is normalize these a little bit, and that's just what I do on the next slide. And again, the moon radius and the Earth radius are just values that you just pull off of Google, and the shadow radius is what we calculated. And what I like to do is normalize these. I'll set the moon radius is equal to 1. Okay, so I just arbitrarily made that 1, and what I want to do then is divide each of these values by the moon radius. So obviously the moon radius divided by itself is 1. The Earth radius divided by 1,737 kilometers is equal to 3.668, and the shadow radius is equal to 2.64. And what that means is, because I'll be looking basically at pixels, so if you have say a disk on a picture that is, say, 10 pixels across, okay, then let's say that's the moon, and that's 10 pixels across. Then the Earth would be 36.68 pixels across, and the shadow radius would be 2.64 pixels across. So this is just a convenience that I'm doing this. Okay, now we come to the reason I was doing all of those calculations. This is a still frame from Mr. Thrive and Survive's video. And what I'm going to do is start by drawing a circle and fitting it to the moon and having a look to see what the size is of the circle. And I confess I did this previously so that I would know about the size to make for the circle so that I don't waste a whole lot of time. So that circle that I just made is 199 times 199 pixels. Turns out 200 is just slightly too big, but I'm going to fit this in and show you that if that's a pretty good fit for the moon right there. Okay? Again, 199 times 199 pixels. Okay, so what I was calculating previously was the radius that we should expect the Earth's shadow to be on the moon, or at the distance of the moon. And that we determined to be 4,598 kilometers in radius, or about 72% of the Earth's radius. And then the other thing I did was normalize everything to the moon. I let the moon equal 1. So radius of the moon is 1. The shadow of the radius of the Earth's shadow then corresponds to 2.64. And the reason I did this is to make it easier to play with this this graphic software. So by 1, that can be 1 inch or it can be 1 pixel. So 1 pixel radius for the moon corresponds to 2.64 pixels for the shadow. So I'll pull out a calculator, and the circle that I just drew for the moon was 199. Okay, times 2.64 is equal to 525 and change. So that is the size of the circle that I need for the shadow. Okay. So let's see if I can draw that. 526, 525, and I'll move that into position here. Oh, what do you know? It fits. See? And that is why the arc of the shadow is what it is. Trigonometry.
With it. Domino, motherfuckers. Say about that.
Now here's the point. Here's NASA. Here's why NASA's busted. Look at the size of the Earth from the moon, guys. Look at the size of the Earth from the moon. Is that going to cause a humongously wide shadow on the moon? Is that what we saw? No. Well, it could be perspective and it could be different things. Well, let's take a look at a couple other little things. You people who want to defend science and NASA to the hilt. It just amazes me. And yet I get hammered if I don't show the right perspective from the sun to the moon from 93 million miles away. And that's not even the point of the video. And yet the same people will defend this and say that made a huge, unbelievably huge shadow on the moon. An umbra and a penumbra. Oh, I got that. Yeah, I got several things about that. So let's take a look at a few other things here. Okay, here we go. How many witnesses do you need, guys? Let's not do a still photo. Let's take an actual film clip. By the way, in case you haven't noticed, pictures of the moon from the pictures of the Earth from the moon, they're starting to grow. They're starting to get larger and larger and larger. Because NASA realizes now they've made the mistake. They've made the mistake of making the Earth look just like the moon does in our sky. They forgot to make it 400% bigger, didn't they? So see the arc angle? See the arc angle that should have been projected onto the moon? Do you see how NASA's busted now? Or are you still going to argue the point? Witness number 2. Look at this. What cracks me up about this is what most of them is. You got about a 90% cloud cover on the Earth. Thank God it's not the Earth. It'll be raining all over the place. Right around the, I don't know what this is supposed to be, how it's oriented, but it's either the equator or right along, let's say, the international date line. I don't know, somewhere has a clear spot, but everybody else pretty much is, they're doomed under, Noah's flood's getting ready to come. Crazy stuff. Here's another thing that's starting to happen too. See how flat the lunar surface is? And some of the still pics show it all, even from a distance, very flat. That's starting to curve now too on some of the newer revised pictures of Apollo or whatever. They're changing them. Because people are starting to pick up that the perspective was all wrong with this. So this is how NASA's busted. I mean, there's what? Probably 500 pictures in this one little loop. Yes, this is the problem. This is the busting. You still going to send me stuff to explain how this is going to cause such a humongous shadow on the moon, such a large arc? And everybody said that was defending science. Oh, the Earth would be so big. from the moon's perspective that it would be that big of a shadow. Yeah, that's really huge there. Tell you what, let's take a look at another one. Want to do that? Yeah, that sounds good to me. Let's do that. All right, here's one more from another Apollo mission. Wow. Earth really grew, didn't it? What a big arc that is. We should be looking at something from this here all the way over here, coming down like this for what we saw. So this is what busts NASA. This is their own film. This is what they said. This is the size of the Earth from the moon. And yet people are going to say this is what causes a humongous shadow on the moon. See, they made a mistake back then. They made a mistake. This is more cloud cover than the last one. I think the point's been made, guys. I mean, you want to defend NASA, fine. But just think about it, if I would have uploaded one video that lied about a balloon launch. You'd have been done with me, I was a liar, and that would have been it, right? And here we got, there's so many videos that bust NASA, it's almost comical. And it's not just joke stuff, it's real stuff.
All right, if you show me a picture of the Earth or an Earthrise, say, from the moon, and you ask me, is the Earth as big as you expect it to be from the moon, or is it too big, or is it too small? I can't tell, because there's nothing to compare it with. I have nothing on this horizon. It's just rock. I don't know what the distance is anywhere on this landscape, so the size of the Earth, in the absence of further information, it's a mystery. You know, if you look at the moon from the Earth, it's always roughly 0.5 angular diameter, but in pictures it varies quite a bit in size. Sometimes it's very small, like this time lapse of the moon. You see, it's a very tiny moon in this picture, and it's quite a bit bigger in this picture. Bigger still here, bigger here. Kind of average size, big, small, big. Now, if I have something on the horizon in the landscape that is perhaps of a known size, for example, this structure, I can probably determine what the size of this structure is, and if I know what the distance is of this ruin, the distance to the camera, then I can determine what its angular width is, okay? And then I can compare that to the moon and say, well, okay, the moon is about the size I would expect it to be, or there's something wrong with the moon. It's too big or it's too small. But in the absence of a structure such as this, I can't tell, okay? So showing me a picture like this and saying, well, the Earth is too small or the Earth is too big, it just doesn't mean anything to me.